So the parent function for simple rational functions. The graph of the parent function, f of x equals 1 over x, is a hyperbola. Do you remember hyperbolas?
Yes.
From conic sections?
9.
Yes, chapter 9. Hyperbola, okay? Which consists of two symmetrical parts called branches. So if you have a calculator in front of you, you might want to try it. 1 over x, just to refresh your memory. If you don't remember what a hyperbola is. Or you can just look at mine real quick. So if I do 1 divided by x and I do the standard window, it's a hyperbola. There's two branches and they're symmetrical. Okay? Anytime you divide by a variable, it becomes a hyperbola like that. So that's what we're going to be graphing. Okay? For the parent function, the domain and range are all reals but not 0. That's only for the parent function. Don't be thinking that's for all of them, okay? The asymptotes are always going to be x equals 0 and y equals 0 for this type of function that looks like the parent function. So any function of that form, which is the same as the parent function, has the same asymptotes, domain, and range as the parent function. Okay? Graph the function and compare the graph with the graph of y equals 1 over x. Draw in the asymptotes. All right, so we're going to graph this function right here. Is it the same as the parent function? Pretty much the same format, right? There's no transformations. There's no h and k going on, correct? All right. So the first thing we're going to do is draw the asymptotes. If there's no h and k, what are the asymptotes?
0.
0. So draw the asymptotes. X equals 0, y equals 0. Those are my asymptotes. The second step you're going to do for graphing these functions is plot points to the left and to the right of the vertical asymptote. That means you're picking x values that aren't on the vertical asymptote. So you're going to pick x values to the left of the vertical asymptote and to the right. So I'm just going to write here, I'm going to go down here and make my left points to the left of the asymptote. So pick some easy ones, you know, like I can't pick 0, so I'm going to pick -1. I'm going to pick -2. And then I would just plug them into my function to find out what y would be. I'm assuming you can do that. Okay? And just for the heck of it, let's just do -4. What would that be?
What's the range of 1?
What's-
Oh, it's supposed to be range.
Yeah, type that on my lunch break. Okay, so let's plot those points. So, let's do to the right now. Let's pick some points to the right up here. Let's pick some points to the right. Pick some easy ones. Just pick like 1 and 2. Maybe that's all we need. Okay? So if we plug 1 in, it's 4. If we plug 2 in, it's 2. So then, the next step says plot those points. So we're going to plot those points. -1, -4, -2, -2, -4, -1. Now they don't touch the asymptotes. The branches don't. Okay? And then over here is 1 and 4, 2 and 2. And these are all symmetrical. So you kind of have to draw them symmetrical as close as you can get them so they look similar to each other. And then you have your branches. So that's not too bad, right? That's a basic one. So the domain is everything but what? 0. And the range is all reals but not 0. Okay? So this is like the first type that you're going to see.
So they're easy?
Yeah, these are the basic ones.
Yeah, well, let's stay with the basic.
All right. now we're going to translate them a little bit. Graphing translations of simple rational functions. So, to graph a rational function of this form, follow these steps. You've seen this stuff before. You've seen h and k before, okay? You draw the asymptotes. X equals h, doesn't it? X equals h. It's whatever the opposite is in here, if you want to think of it like that. Some people like to think of it like that. So if this was a 3, then it's going to be x equals 3. Okay, if it's minus 3. If it's plus 3, it's going to be x equals negative 3. Some people look at it like that. And then your y is simply your what? Your k. Y equals k. So your asymptotes are just going to be whatever h and k are. Plot the points to the left and the right of the vertical asymptote. So you only have to consider the vertical asymptote, because those would be the x values that you choose to plug in. And then draw the two branches of the hyperbola. Okay, so I'm going to stop and just take a look real quick. So here we have a constant over a linear, correct? Constant over a linear. This is one type. Here, we also have a constant over a linear, don't we? And I'm pointing this out for a reason, because there's certain different rules that you have to follow when you start getting away from these types. You start getting linear over linear and stuff like that. So, all right, so the first step says draw the asymptotes. Okay, so what is my vertical asymptote going to be? Yeah, it's the opposite of whatever's in there. And then my horizontal asymptote will just be 2. So sketch those on your graph. X equals negative 3 and y equals 2. Okay? Then you plot points to the left and the right of the vertical asymptote. So I'm going to go down here and write left. Just pick some points to the left. Make it easy on yourself. Sometimes if you look at the function, you can pick some easy points. I just chose negative 6 and negative 4. I cannot choose anything bigger than negative 3 because it's got to be to the left of the asymptote. When I plug those in, I get 4 and 8. You have to do this without a calculator. So, and then to the right of the asymptote, so it has to be bigger than negative 3 to go to the right of the asymptote. So I'm just going to pick like negative 1 and maybe 0. And when I do that, I plug in negative 1 up here. I'm going to end up with negative 1. If I plug in 0, what do I end up with? Do it in your head. 0. Because 0 plus 3 is 3, negative 6 divided by 3 is negative 2, plus 2 is 0. And when I was doing the homework, I had to like write it down. I do, and I don't do it all in my head. So, don't worry about it if you can't get it in your head. All right, now draw the two branches of the hyperbola with those points. And you should be able to come up with pretty close to what it looks like. Negative 6 and 4. And you got to kind of try and draw them as symmetrical as you can, even though your points may not be. All right? Not too bad? Okay, what's the I'm sorry, did I hear a question? What's the domain? Yeah, and it's real easy because it's just, it can't be what the asymptote is. So it's all reals but not negative 3 for x's. And all reals but not what? 2. Okay? So that's not too bad. All right. This one, you just do the same steps. So the first thing I always do is the asymptotes. It's just not written out for you here. So x equals what? 2, because it's the opposite of what's in here, where h is. And y equals what? 1. So sketch those. What's the next step? Yeah. Pick points to the left of the vertical asymptote and points to the right of the vertical asymptote.
You do it wrong.
Ugh.
Yeah.
Did. Amateur hour. You're right. I'll draw them in blue correctly, okay?
Oh my god.
Or we should just skip this problem.
No, we shouldn't skip this problem. Okay.
Oh,
All right. Isn't that beautiful?
guys.
It's beautiful, isn't it? Okay, left and right. So I have to be to the left of 2. So I'm just going to pick some easy numbers, maybe 1 and 0. Okay? When I plug in 1 to this function, I get -2. When I plug in 0 to that function, I get -1/2. That should be enough, we'll see. And then to the right, I'm just going to pick 3 and maybe 4 and see what happens. You might get some fractions or decimals, and that's okay. When you plug in 3, you get 4. What do you get when you plug in 4?
I'm guessing it's going to be 5.5.
2.5.
2.5. I heard it. 2.5. 2.5. Because the denominator becomes 2. So you have 3 halves, or 1.5 plus 1. Okay? So now let's plot those points. Okay? I know this is going to be a little bit funky looking, but that's okay. Over 1, down 2. Over 3, up 4. Over 4, 2.5. So, that's not so bad, huh? So far, we've looked at constant over linear. That was the first part of 8.2. Okay? Oh, thank you. We should also, of course, do domain and range. Domain is everything but what? 2. All reals but not 2. And the range is all reals but not what? 1. Now I have to show you one more thing, because you're going to see something that is on the worksheet that is not on here. So just write this function right here. Let's talk about this. In the denominator of this function, we said that it had to be -3, right? The vertical asymptote is -3. If I plug in -3 here for x, what do I get in my denominator? 0. Okay? So that means if you get something like this and you have to determine the vertical asymptote, you have to figure out what x would make the denominator 0. So you would just do 2x minus 1 equals 0. Some of you like to do this in your head, and you make mistakes sometimes. So you add 1 to both sides and divide by 2. So what would the vertical asymptote then be? 1/2. So that's slightly different, but it's still making the denominator 0, whatever x value that is. Okay? Does that make sense to you? Because that's really what you're doing when you're saying x is -3. It makes that denominator 0. And that's what x cannot be. You can't have 0 in the denominator. That's what the vertical asymptote is for. Clear? Okay. All right, moving on. It's the last page. This is slightly different, and as Kyle just said, it's a linear over the linear. So it's a little bit of a different process, slightly, but not too much. You still do basically the same thing. Okay, so here we have a linear over a linear. Draw the asymptotes. All right, the vertical asymptote still comes from the bottom. You still have to determine what makes that denominator 0. And this is an easy one, obviously. That's an easy one because it's just going to be what? 1. So you still just do this. X equals 1. That's my vertical asymptote. Put your phone away, Wes. Okay? Now the horizontal asymptote is slightly different. This is slightly different. The horizontal comes from the coefficients in the front. So y equals a divided by c. Do you see where a and c are up here? Okay, so what's my a and my c here? 4 and 1. 4 and 1. Because there's a 1 in front of here. So my y is going to be 4 divided by 1. So my y is 4. So that makes it, that's what's slightly different when you have a linear and a linear. Okay? So graph those. X equals 1. Super paranoid about making mistakes.
So you don't mess it up.
God. Being an amateur. Okay? All right. Now you do the same process. You plot points to the left and to the right of the vertical asymptote. Those are the x's that you pick. So I'm going to say left. I'm just going to pick a couple of points. Has to be to the left of 1. So I picked -1 and I picked 0. Then you kind of just go up here and you plug those in and you find out that this would give you a 3 and 0 would give you a 2. And I realize you cannot use a calculator on this, so you kind of got to use your brain.
Not my brain.
Your brain.
Oh no.
And to the right of the vertical asymptote, so greater than 1, so I just picked 2 and 3. And that was 6, and this is 5. All right, sketch those points.
This is so difficult.
Okay. Not so symmetrical, but close enough. All right. Domain is everything but what?
1.
And range is everything but what?
4.
Okay. All right, let's do this last one together. Asymptotes. So x is going to be whatever makes that denominator 0. And if you can't see it, just set it equal to 0. Correct? And then y is equal to the division of a and c up there. So it's going to be -2 divided by -1, which is +2. Okay, so sketch those. Okay? And then I'll just give you the points for the sake of time. -3 and 7, -4 and 4.5, -1 and -3, 0 and -1/2. You all mean, you know what I mean when I say left and right, correct?
Yeah.
Left of the vertical asymptote, right of the vertical asymptote. Graph those points. So, not so bad, huh?
I mean,
We can do domain and range, but I think you know what they are. But what I want you to be aware of is when you're given a set of functions to graph, you have to decide if it's a constant over a linear or a linear over a linear and follow the different, slightly different steps. Not much. Got it? Okay. All right, I'll put the worksheet out.